I'm Eric Yen, the Product Marketing Manager for Electro-Hydraulic Operator, also called the EHO actuator. This is a smart EHO designed for fail-safe applications. The smart version has diagnostics, alerts and alarms, positioning and modulating capabilities, and can connect to common communication protocols. In this video, we will talk about how to set up and commission the smart EHO. These steps can be utilized for the standard EHO as well. Some of the key components of the EHO are the hydraulic manifold, electronic enclosure, separate terminal chamber, the motor, reservoir, hand pump, local display, the Scotch yoke actuator, the power module, the control module, the spring module, and an optional accumulator. Please refer to the ION manual for important safety precautions. Each unit is unique and you should follow the schematics and wiring diagrams that came with your unit. Following along with your IOM manual, we are covering sections 4.2 to 4.9 from initial check of the unit through functional test. At this point, we assume the actuator has been mounted to the valve and the electrician has already landed power and control wiring per the wiring diagram provided with the unit. If you have any questions on mounting the actuator to the valve, setting the mechanical stops of the EHO, or making the electronic connections to the EHO, please consult your EHO IOM manual. For setup and startup of the smart EHO, you need the following tools: standard Allen wrench set, small adjustable crescent wrench, small zip ties, small Phillips screwdriver, small flathead screwdriver, multimeter, primary power source, deep socket set with a small impact drill, nitrogen charging kit, supplemental quantity of hydraulic fluid, IOM, bill of material, general arrangement drawing, schematic drawing, and wiring diagram. Check to ensure all hydraulic tube fittings are tight. Vibration during shipment may have loosened connections. Note, depending on your configuration of the actuator, you may have additional fittings on your unit that will require attention. Please make sure to consult your schematic, drawings, and the physical unit to make sure you have tightened all the fittings. Visually inspect the unit to make sure tubing, hand valves, gauges, and other equipment have not been damaged. Verify that the flow control valves are fully open by turning the valves completely counterclockwise. If your flow control valves are not fully open, your actuator may operate slower than expected. Use your Allen wrench and turn counterclockwise completely to ensure the flow control valve is fully open. After you open the flow control valve, use your wrench to tighten the hex nut. Once you've tightened the hex nut, make sure you put the caps back on the flow control valves. Ensure the lockable manual bypass valve is closed. Ensure that your three-way selector valve is in the correct position when your accumulator is in the open position. Refer to your schematic for your unit. If you have an accumulator, ensure the accumulator drain isolation valve is closed. If the red knob is perpendicular to the accumulator drain isolation valve, it is in the closed position. Ensure the nitrogen blowdown and fill isolation valve is closed. Electrical connections should have been made to the separate terminal chamber. If not, please consult your wiring diagram on how to connect to the EHO. If you have an AC solenoid, make sure the AC solenoid is properly powered. If a circuit breaker module is provided, ensure the circuit breaker is turned to off. Caution: before the actuator is stroked, check to see it has been filled with fluid to the proper level. Next, we want to verify the hand pump operation. Read the hand pump instructions on the yellow tag. To operate the hand pump isolation valve must be fully closed in the clockwise direction. If not, pressure will build up when operating the hand pump. Use a 5/32-inch 4mm hex wrench. Turn the valve counterclockwise to open or clockwise to close. Be sure to reopen the hand pump isolation valve when you no longer require the hand pump to operate the actuator. Leaving the hand pump isolation valve in the closed position, local or remote operation of the actuator will not work properly, and oil may spill out of the reservoir when operating via the electric motor. Use the handle supplied with the pump to raise the pump clevis. To insert the handle into the hand pump, loosen the hand pump bar screws. Insert the handle and tighten the hand pump bar screws. You will pull the pump handle down to discharge the hydraulic fluid into the cylinder of the actuator. Repeat operating the handle until the actuator has completed its power stroke. You can verify the position of the actuator by viewing the mechanical dial position indicator. After confirming the actuator is fully open, push hand pump bypass located below the hand pump and push the pump handle down. Remove the handle. Slowly open the lockable manual bypass valve to allow the actuator to spring return to its fail-safe position. After the actuator has returned to its fail-safe position and pressure has been released, close the lockable manual bypass valve. Open the hand pump isolation valve counterclockwise to return to automatic operation. Ensure the lock nut is tight to make sure the isolation valve is locked in place. Check reservoir to see the hydraulic fluid is at the proper level. Important: the lockable manual bypass valve must be closed to enable any mode of operation. Hand pump isolation valve must be open for normal operation. The hydraulic test is to discover if any leaks have developed in the hydraulic fittings during shipment that may cause the EHO not to function properly when the EHO is commissioned. The components you'll be using in this section are hand pump isolation valve, manual bypass valve, hand pump bypass, reservoir window. Open hand pump isolation valve and ensure lockable manual bypass valve is closed. Using a 5/32-inch 4mm hex wrench, turn the valve counterclockwise for open. Once the hand pump isolation valve is fully open, turn the hex nut clockwise until tight. Then use your wrench to fully tighten. Replace the cap. Using the supplied handle, stroke hand pump 4 or 5 times and stop. Allow the unit to remain under pressure for a few minutes and check all fittings for leakage. If any leakage is found, release the pressure by slowly opening manual bypass valve. Repair any leakage and repeat the hand pump pressure test again. Check the reservoir to see the hydraulic fluid is at the proper level. You want to ensure the motor rotates in the direction as designated on the decal on the motor tag to ensure the EHO will function as intended. The components you'll be using in this section are the motor pump coupling inspection ports, local off remote selector switch. Turn on the electrical supply to the unit. If an optional circuit breaker module is supplied, turn the circuit breaker to on. Turn the local off remote selector switch to local. Ensure flow control valves are adjusted fully, counterclockwise for maximum flow. Use your wrench to loosen the nuts. Use your 5/32-inch or 4mm Allen wrench turning counterclockwise until fully open. Use your wrench to tighten the hex nut. Replace the caps. Open inspection port on the side of the unit to observe the rotation of the motor pump shaft. While observing the inspection port for motor rotation, turn the open-close selector knob to open to power stroke the actuator, and immediately turn the selector knob to the off position. Verify the motor rotation is consistent with the decal on the motor tag. Make sure the local off remote selector knob is toggled to the local position. Use the open-close control knob to power stroke the actuator. The electric motor will start to run, driving the hydraulic pump. At the end of the power stroke, toggle the local off remote selector knob to off. Slowly open the lockable manual bypass valve and allow the actuator to spring return back to the start position. Once in the start position, close the lockable manual bypass valve. In this module, we're going to show you how to do self-calibration. Before we get started, let me introduce you some of the features on the local display module that you'll be using for self-calibration. First, we have the control knob. The control knob is used to answer no and yes when you navigate through the setup menu. On the right, we have the selector knob. The selector knob is used to navigate through the setup menu. You can go back, stop, or next as you navigate through the setup menu. In order to get in the setup menu, you want to have the navigation knob or the selector knob in the stop position. And for the control knob, you want to toggle yes, no, very quickly, like this. You know you're in your setup menu when you see the LOR LED flashing and it reads SU for setup. Right now, your unit is asking if you want to go into setup. So you want to take your control knob and toggle yes. When you toggle yes, you'll see the FN appears on your screen. FN is the find function. This will help you automatically jump to the self-calibration menu in your Smart EHO. So hit yes, and you're going to see two lines. So these lines, what's asking for is to find the self-calibration feature. So to jump to the self-calibration feature, you have to hit no till you see SC appear on the screen. Once you see S, then you hit yes, and it'll ask you to fill in the second digit. So you hit no till you see C. And once you see C, you hit yes. So next you see PC. PC is your passcode. In order to make any changes to the EHO, we need to enter a passcode. So we're going to hit yes. And it's going to ask for a 4-digit passcode. So here it's asking for the first 2 digits. In this case, the Smart EHO is set up for a passcode of 0000. Please check your IOM manual to make sure that you have your passcode ready. So hit yes once you get to the passcode digit that you want to select, and yes again. Now it's flashing again for the first digit, and this would be your digit 3 and 4. So I hit yes again, and hit yes again. You know that accepted your passcode if it shows SC. When you see SC on your screen, that means you're at the self-calibration menu. Typically, you don't need to change any of these settings in self-calibration. Now you hit yes,
And now you'll see some of the parameters for self-calibration. So once you go into self-calibration, you're going to start setting the parameters for self-calibration. The first parameter you'll see is ST, and this is your cycle count. So right now it has 3, and what that means is your actuator is going to stroke open and close 3 times for self-calibration. This helps set the limits. So if you want to increase the number of strokes, you would go to no. If 3 is acceptable a number of strokes, you just go to yes. In this case, we'll leave it at 3 and we'll hit yes and go to the next parameter. The next parameter in self-calibration is PU, which is pressure unit. 0 is the default selection. 0 means PSI. 1 is bar, and 2 is KPA. If you want to change the selection, similar to ST, or your cycle count, you would hit no, and it will increment the number to get to the pressure unit of your choice. In this case, we'll stay with PSI, so we'll hit yes. The next parameter for self-calibration is PS. PS is pressure spike. Pressure spike is the maximum hydraulic pressure during self-calibration. For PSI, you can make a selection between 5 to 50, which translates to 500 to 5,000. Right now, the unit is set to 2400, which is factory set. If this setting is appropriate, you just hit yes and go to the next parameter. The next parameter for self-calibration is PR, maximum operating pressure. This parameter can be between 5 to 50, which, similar to the last parameter, equates to 500 to 5,000. Right now it's factory set to 2,000. And if this parameter is set properly, you just hit yes to go to the next parameter. If you have a thermal accumulator, the next parameter you'll see is TP. This is thermal accumulator pressure. For PSI, your selection is 5 to 50. And like the other 2 parameters, that equates to 500 to 5,000. This parameter is factory set and typically won't need to be changed. All right, we'll hit yes to go to the next parameter. The next parameter here is self-calibration test. It's big S, small c. When you're ready to run self-calibration, you'll hit yes on this parameter. When you hit yes on this parameter, your actuator is going to open and close 3 times based off of your setting. It's going to run up to 86 degrees here on this unit and go back close. And it's going to do this 2 more times. Depending on how your mechanical stops are set, it may run anywhere between 85 to 95 degrees. Once self-calibration is complete, you're going to get a status update. SP stands for self-calibration passed. SF stands for self-calibration failed. In this case, we were able to successfully perform self-calibration. To exit self-calibration, hit yes. You'll see SC appears on the screen. All this means is you jumped up the setup menu back to self-calibration. In order to save these settings, you want to find the SA parameter. In order to do that, you can take the navigation selector knob and go to next. To save your self-calibration settings, toggle yes when you see SA. The next menu you see is EE. E is the exit setup menu. Once you hit yes, you go back to normal operation. You have now successfully self-calibrated your smart EHO unit.
If limit switches are supplied with the smart EHO, the limit switches will be factory set. The purpose of the limit switches are for position feedback, and further adjustment of the limit switches are typically not required. If limit switches require adjustment, please make sure you disconnect power to the unit before changing the limit switch settings. You will be opening the electronic enclosure where components receive live power. The limit switch adjustments are found in a cover compartment in line with the valve stem and on the opposite side of the control box. Remove the limit switch compartment cover by loosening the 4 corner bolts retaining it. All covers have tapped holes for jack screws to aid in removing the cover. Use caution to not allow the cover to bind during removal. After removing the cover, you can use one of the screws to hold the compartment cover in place while you are working inside the unit. In this video, we have removed the encoder that resides on the top of the limit switches for viewability purposes. You can adjust your limit switches without having to remove the encoder. If the actuator is being installed in the hazardous area, use extreme care. This procedure requires the limit switch cover to be open while electrical power is connected to the unit. Follow these steps only when the atmosphere is free of explosive gases. The open and closed limit switches, highlighted here in green, are operated by target magnets, highlighted here in orange. The target magnets are mounted in a plastic disc that rotates with the actuator stroke. They must align above the limit switches in order to provide accurate position feedback. In order to adjust the limit switches of the smart EHO, you will need to move the target magnets. First, ensure the actuator is in the closed position. Push down on the target magnet for close, limit switch 2, and move clockwise until it's off the limit switch. Now, push down and slide the target magnet for close, limit switch 2, counterclockwise until it's aligned with the limit switch. It is important to always adjust a target magnet in the opposing direction of the valve travel to get an accurate setting. Then, you will need to verify continuity between the target magnet and the limit switch using a multimeter. Refer to your wiring diagram to determine which terminals you need to check for continuity. With the selector switch set to local, toggle the control selector knob to open and allow the actuator to travel to open position, rotated fully counterclockwise. Push down and slide target magnet for open limit switch 1 counterclockwise until it's off the switch. Now, push down and slide the target magnet for open limit switch 1 clockwise until it is aligned with the limit switch. Then, you will need to verify continuity between the target magnet and the limit switch using a multimeter. Toggle the control selector knob to close and allow the actuator to rotate clockwise to the fully closed position and check to see closed limit switch 2 is working. Verify continuity with your multimeter. Cycle the actuator open and close a few times, checking the settings of closed limit switch 1 and open limit switch 2. If you have a fail-safe open limit switch adjustment, you will follow the same procedures to set open limit switch 1 and close limit switch 2 as you did for the fail-safe closed limit switch just discussed. If your unit utilizes 4 switches, limit switch 3 open and limit switch 4 close, for intermediate position feedback, adjust in the same manner. Look at these switches on the wiring diagram for exact configuration. If the smart EHO actuator is supplied with optional ESD, before operating a motor-powered stroke, a customer-supplied ESD signal must be present and solenoid valve energized. Ensure the lockable manual bypass valve is closed and the hand pump isolation valve is open. Using a 5/32" or 4mm hex wrench, turn the valve counterclockwise for open. Once the hand pump isolation valve is fully open, turn the hex nut clockwise until tight, then use your wrench to fully tighten. Replace the cap. Put the local off remote selector switch into local mode. Use the open-close selector knob to power stroke the actuator. The electric motor will start to run, driving the hydraulic pump. The hydraulic pump draws fluid from the reservoir and pushes it into the Bettis G or E series hydraulic cylinder. As the actuator strokes, the spring will compress in the spring return module. If an accumulator is provided, the hydraulic pump will also start charging the accumulator. The hydraulic pump will continue to charge the accumulator till the accumulator is fully pressurized, as per setting on the pressure switch. The hydraulic pump motor will stop once the accumulator is fully charged. This accumulator pressure will be used for power strokes of the actuator until the accumulator pressure drops to below the predetermined set point. The hydraulic pump motor restarts again to recharge the accumulator until it reaches the set point of the pressure switch. Note, when the actuator power is connected, the hydraulic pump motor does not immediately start if the accumulator pressure is below the predetermined set point. The motor runs only after there is a command to open or close the actuator. Toggle the open-close selector knob to stroke the actuator to the fail-safe position. Check all hydraulic lines and fittings for leakage and repair as needed. Cycle the actuator open and close a few times to ensure operation. Toggle the open-close selector knob to power stroke. While the motor is running, switch the selector knob to off. The motor and actuator will stop. When the selector knob is in the stop position, the accumulator does not charge even if it goes below the charging pressure. Set your selector switch back to local and toggle the open-close selector knob to fully power stroke the actuator. Turn the selector switch to remote and toggle open-close selector knob open and close to make sure the actuator does not stroke. Turn the selector switch to local. Rotate the open-close selector switch to close and open positions to ensure control has returned. If the actuator successfully opens and closes, the actuator has completed the local functional test and the Bettis Smart EHO actuator is now operational and ready for local service.